Hello friends, welcome to another video of Zeta Axis, and today we are going to discuss about aluminum reserves and its production in India. Now if you see the global producers, then China is the leading producer of aluminum, with India being a very distant second position. China also has the highest aluminum reserves across the globe. Now the major ore for aluminum is bauxite. However, bauxite is not typically an ore, but it is an aluminous rock that contains hydrated aluminum oxide. It also has minor proportion of iron oxide, silica and titanium. Therefore, most of the industries which produce aluminum, they also produce iron oxide in some amount. Now, alumina can be extracted from bauxite by using a Bayer process. Remember, this process is used to produce alumina from bauxite, where alumina is different than aluminium. Alumina is basically an aluminum oxide, while pure alumina has only aluminium. So this is an intermediary compound. Aluminum is produced from alumina. So Bayer process helps us extract alumina from bauxite. It has mainly 4 stages: digestion, clarification, precipitation and calcination. Now in this process, what happens that bauxite ore is taken along with caustic soda and a solution is formed. The alumina component of bauxite dissolves. However, the other impurities do not dissolve. So then it is taken in another container where it is stirred and it is allowed to settle. The impurities they slowly settle down and they are removed. Now the solution is taken and it is used for crystallization. Here we get aluminium crystals. Alumina crystals are there, and then it is dried here to get alumina. The details of the process is over here. Here we can see in the digestion, after milling, bauxite is mixed with caustic soda. Under high temperature and pressure, alumina dissolves from the bauxite ore. Clays, they do not dissolve in the caustic soda. Undissolved impurities settle down as fine red mud, which after a few recycling steps is discarded. So some of the impurities just settle down. Again, in clarification, we see undissolved impurities like iron oxide and silicon dioxide are removed as red mud through sedimentation and filtration. In this process, there is this container where it is constantly stirred, which helps in further cleaning and sedimentation. In the third stage of precipitation, aluminum solution is cooled. The purified or filtered aluminum solution is taken and it is cooled, and aluminum trihydrate crystals are precipitated. You can see that these crystals they precipitate from this solution. Some seeding is required for this crystallization. And in the fourth stage, we take aluminum trihydrate crystals and they are heated in a kiln at a very high temperature. We can see that they are heated in a kiln over here. Then it removes water and convert them into fine white powder as alumina. So on the output of this, we get alumina. Now if you see the difference between aluminium powder and alumina powder. So aluminum powder is pure aluminum, Al, while alumina powder is Al2O3. It is an oxide of aluminium. You can see the density, it has lower density, it has higher density. Electrical conductivity is higher of aluminium, while alumina is an insulating material. We can also see other properties if you like. Now, if we see the process by which aluminium is extracted from alumina. So here we can see that alumina has Al2 and O3. So for this, we use electrolysis process. Here, a solution is made. Alumina is dissolved in molten cryolite, a sodium aluminum fluoride compound, and which lowers the melting point of mixture and allows easier electrolysis. So the alumina powder that we got, it is mixed in this molten cryolite and formed a solution. That solution is put in this container and electrolysis is done. And the electrolysis cell, the molten mixture is placed in a steel cell lined with graphite. The lining is done with graphite because it provides carbon, which acts as a cathode. Now electrodes, carbon anodes, positive electrodes are inserted into the molten mixture. It is inserted over here and now electrical current is passed. We can see that Al3 plus ions are formed, which are attracted to cathode because of their charge, and O2 minus ions are attracted to the anode, and at the anode they react with carbon and they form carbon dioxide or carbon monoxide. So these two gases are released in this process, and electricity is required for purification of alumina to aluminium. Therefore, generally, aluminium plants are located near a source where there is cheap electricity, generally hydroelectricity. So you will see that in Odisha, near Hirakud Dam, there are quite a few aluminium producing plants. So let's see the bauxite reserves. Odisha has highest bauxite reserves in India, followed by Chhattisgarh, Andhra Pradesh, Gujarat, and so on. And if we see the production of bauxite, then we have Odisha, followed by Jharkhand, Gujarat. But Odisha produces more than 3/4 of the bauxite. Now here are the regions where we have bauxite in India. But if you see the major production, then it comes from these regions. This is in Odisha, mainly Koraput district. So here is Koraput and Rayagad, which are the major producers. Here is the map of Odisha where we can see the regions where bauxite is produced, and Rayagada, Koraput and Kalahandi. These are the major three districts where we see most of production. There are also reserves in other places. So these districts are the districts where there are bauxite reserves, but these points, they indicate the mine locations. In Jharkhand, we can see that there are some reserves in Palamu, Latehar, Lohardaga, Gumla, Girid and Dumka, but mines are located mainly in Lohardaga, Gumla and Latehar. Similarly, if we see Gujarat, then reserves can be seen in these districts: Bhavnagar, Amreli, Junagadh, Porbandar, Devbhumi, Dwarka, Jamnagar, as well as Kutch. But production mainly occurs from Kutch region. Similarly, in Chhattisgarh, we can see that there are districts which are having aluminium reserves, but most of the production occurs over here. Now, this is the map of the regions where bauxite mines are located. And these are the regions where we see that there are plants which produce alumina as well as aluminium. So the blue color indicates the plants which produce alumina, while red color indicates the plants which produce aluminium. If you see in detail, then these are the plants which produce aluminium. We have Nalco in Angul, Hindalco in Hirakund, again Vedanta, which is a very large producer, you can see over here, is located in Jharsuguda. Then Balco is there in Korba, Hindalco in Singrauli and Hindalco in Renukut. So you can see that these are the plants which produce aluminium in India. And if we see alumina, then we can see these are the plants which produce alumina. We have most of the production of alumina in Odisha. There is Hindalco Belgavi, Hindalco Renukut, Hindalco Chotamuni. You can see that most of the plants are owned by Hindalco. There is one by Nalco and another by Vedanta. So with this, we will conclude our video on aluminium production and reserves in India. I hope you have liked the video, and if you like the video, then do subscribe to the channel and share it with your friends. Thanks for watching the video.